All right, we're going to look at a little review to get ready for our quiz on sections 1.1 to 1.3. So we just have some sample problems we're going to go over to kind of prepare you. So this first one, it gives a study about hoping to control crop damage of certain species of beetle. A researcher plans to test 2 different pesticides in small plots of corn. A few days after the application of the chemicals, he'll check the number of beetle larvae found in each plant. The researcher wants to know if either pesticide works and whether there's a significant difference between the effectiveness between them. To do this, he randomly selects pots of corn to get 2 different chemicals. So essentially, we have this big field, okay, and we're going to put it into plots. And then half of the field, we're going to give a certain chemical, chemical 1, and the other one, chemical 2. So maybe chemical 1 here, chemical 2 here. Maybe you do it in different spots. Maybe you do half of the left, half of the right. So you just want to basically give half of it the first chemical and half of the second chemical. Then you want to compare how effective they are at stopping this beetle species. Okay? So is this an observational study or an experiment? Well, this would be an experiment because you're actually changing it, right? It's an experiment because you are changing the conditions. So you're not just observing what's happening. You're just not seeing what naturally happens with these beetles in this field. You're actually deliberately trying to put this chemical on to stop it. So that is what we're going to call the treatment. The treatment is the chemical that is applied. That's what you are trying to change. You're trying to make the beetles less in one field versus the other, so the chemical you're getting is supposed to stop that, right? So this experiment, that is going to be our treatment. Okay. Now the population, what we're talking about, the population is essentially going to be the entire field. The entire field of corn is our population. Because we want to see how these chemicals are going to affect these corns, right? So if I was going to design this, the big thing is, just remember, we are going to split the field into equal parts. So we're going to kind of split it into equal parts, however. And so once we split it into equal parts, we will randomly apply the chemical to the different parts. Now, so we're going to split it up. We're going to, whatever sections you want to do. So I'm going to split into equal parts. I'm going to randomly apply the different chemicals to these different parts. So what you might have is you might have something where you have your field like this, and maybe I split it into rows and columns. And then maybe I randomly select 10 spots, and maybe I pick this one and this one and this one. So I randomly pick these, and these are going to get my first chemical. So if you randomly select, hopefully you'll get kind of a nice mix of the different areas. And then I'll put chemical 2 in the other ones. And so what we do is we're hopefully eliminating any factors that might influence this chemical spread. So maybe one side of the field is closer to a river and it has better water. So we want to try to just eliminate all those different features as we go through. So the big thing is we're going to apply these chemicals to different parts, and then we're going to compare how many beetles survive, because we're trying to avoid these beetles in these areas eating the corn. Because we want to kind of get rid of that. We want to kind of get rid of all these beetles. We want to see which one will do a better job. If I look... All right, let's look at the next question. So this one says we have a list of popular baby names in the U.S. We want to label each name, and using line 126, find a simple random sample of 3 possible baby names. So you have to name your baby, and you just want to randomly do it. You don't want to do any thought to it. So we have these names, so I will first randomly assign these to numbers. So maybe 0, 1, 0, 2. So I'm just going to do it this way, however I want, right? So this is how I'm going to label it. And then I'll find some random numbers. These were the most popular baby names a couple years ago. So what I'm going to do is I'm going to use line 126 to find these numbers, right? So here is my random digits table. So if I go here, I'm going to look for numbers from 1 to 20. So 69, 27, 19 is my first one I see, so that's a good one. 93, then I have 13, that's a good one. No 60, no 89, no 74. 19 again, but I can't pick it twice. 27, 75, 67, 88, 74, and 14. So I have 19, 13, and 14 as my choices. Now here, what those numbers are. So I have 19, 14, and 13. Now, this happens sometimes. We talked a lot about this. So this is going to be Elijah, and it's going to be Aiden, and it is going to be Noah. Now, ironically, these were all male names, so that certainly could be a problem, depending on what you're trying to do. So there you go. Now, 6 says, could I create a stratified sample where I have 2 male and 2 female names? So above I just had 3 random names. What if I wanted 2 male and I wanted 2 female names out of this list? Okay. So what I'm going to do is I'm going to go to my line and I'm going to use line 130. So I'll first pick the 2 males. So for males, I'm looking for something between 11 and 20. So I'm going to see, do I have any numbers between 11 and 20? So 69, 05, 16. So 16 is my first. Then 48, no, and then 17. So I have 16 and I have 17. Those are my 2 male numbers that came up. And I want 2 female names. So if I want 2 female names, I got to go 0, 1 to 10. And I could keep going. I could start at 130. I'm just going to keep going. So 87, 17, 40, 95, 17, 85, 53, 40, 48, 98, 72, 1, 97, 24, 50, 50, and then 7. So I have 1 and 7. So number 1 and number 7 were my 2 female names. Now, of course, what I want to make sure I do is I want to actually say what those names are, right? So I have Caden, and I have Grayson. And then over here for female, I have Sophia. And I have Aria. Probably Aria. There you go. So the first one, I just picked 3 random baby names. They just happen to all be male. And then the second one, I picked my 2 male and 2 random female, just so I make sure I have an equal number. So if you did not know the gender of your child, you might just have to have 2 ready or something like that. All right, this last thing, let's talk about this. So a poll asked 2,000 Americans whether they enjoyed watching sports on TV. Of these, 1,300 said they enjoyed watching sports on TV. What proportion of Americans enjoy watching sports on TV? Is this a statistic or a parameter? So really all we know is we surveyed 2,000 Americans and we said 1,300 enjoyed it. Now, that is obviously not all Americans. So that is going to be our sample statistic P hat, because this is not the whole population. This is just a part of it. So P hat is going to be 1,300 out of 2,000. So that is 0.65. Now, so 65% of our sample said they did enjoy watching sports on TV. Now, that certainly could be true for the whole population, or it could be much smaller. So what we're going to do is we're going to try to get an interval to estimate the parameter, right? We only know the statistic, but we're going to use that to try to estimate the parameter. So in that respect, B says, what is the margin of error? If you recall from section 3, the margin of error is given by this formula, 1 over the square root of n. Now, n is our sample size, which in this case is going to be 2,000. So what we'll do is we'll do 1 over the square root of 2,000, and that will give me my margin of error. So this is going to turn out to be 0.022. So what we know is we know our statistic was 65%. In our margin of error, if we take 0.022 and take it as a percent, that's 2.2%. Okay? So construct an interval. Remember, the interval is going to be 65% plus or minus my margin of error. And this is going to give a region for us to estimate the proportion of all people who like sports. So if I add and subtract that, I'll get 62.8%. That's if I take 65 and subtract 2.2. And then I will add it on as well and get 67.2%. So what this means is I'm about 95% sure if I did survey everyone, if I surveyed everyone in the population, the percentage of those who would enjoy watching sports and TV is somewhere between 62.8 and 67.2. All right, let's look at a couple more examples of those kind of things. So here's another kind of problem. This says, if 39% of teachers in a sample of 250 teachers said they prefer year-round school, find and interpret the 95% confidence interval. So very similar to what we just did. So first thing I have to do is find the margin of error, which is 1 over the square root of n. And in this case, n is how many I surveyed, which is 1 over the square root of 250. So my calculator tells me that's going to be 0.063 or 6.3%. Now, the nice thing is it already gave me the 39%. I already know that 39% of these teachers do that. So my margin of error is simply just going to be 39% plus or minus that margin of error I just found. So if I add that number on, I'm going to get 32.7. Oh, I'm sorry, if I subtract it. And then if I add it on, I'm going to get 45.3. So in essence, I'm saying if I ask every single teacher in the world between 32.7 and 45.3 would prefer to go to school all year round. All right, so let's look at another problem. This is another one where we're going to pick a random sample. Obviously, you can see these intervals and these random samples are pretty stressed, so obviously something pretty important for you to study, along with all your other notes. You should obviously study all your notes, all the sections we did. That'll be important. So this is the number of departments at a college. These are my different departments. So I want to pick some random departments. So it says we want to randomly select 6 departments and sample all of their students. Okay? So I have to pick 6 departments from this list. So first thing I'll do is I'll label. So I'll go 0, 1, 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm just going to label them. I mean, there's lots of ways to label. Now, I might be in trouble by doing this because obviously you can see line 116 here. We might have to pull up our random number chart if it's too big, just to go a little further. But let me go ahead and just put all these here. So they're 27. So my line 116 starts here. So my first one is 14. So that would be the history department. 45, 92, 60, 56, 31 is too big, 42, 48, 3. 3 is the art department. 71, 65, 10 is the education department. 36, 22 is the philosophy department. 35, 4 is biology, so that is 5 I have so far. 90, 61, and 18. So barely worked out okay. So the 6 departments I'd picked to talk to all their students are art, biology, education, history, music, and philosophy. Now, the last thing we're going to look at is talking about our different sampling techniques: voluntary response, convenience, simple random sample, stratified, and systematic. So each of these is going to be one of those. So if I survey every fifth person leaving a movie theater, so skip 4, survey 1, skip 4, that's systematic. So that's what that one's going to be. Okay. If I survey every person who attended the 7 o'clock showing of this movie who wanted to be part of the sample, so the key thing is they want to be part of the sample. They're volunteering, right? So that's just going to be voluntary response. So I randomly select 5 people from each showing. So each movie, each showing that night, I select 5. That's going to be stratified because I'm taking some from each group. So I'm splitting them up by like what time they saw the movie. And then I'm surveying some. D, I'm going to survey your friends. Well, that's easy. So if it's friends, that's going to just be convenience because that's who was easily to talk to. And then finally, it says each person who sees the uninvited is assigned a number. You randomly select numbers to determine who's surveyed. So like we've done, that's just a random sample, simple random sample. We have everyone gives a number, and then you pick random numbers. So these were just some quick questions to review for our quiz. Obviously, I would just hope that you would study your notes, look at our assignments as you prepare to take tomorrow's quiz.